Hello, everyone. My name is Will Carter, and I'm with CSIS Strategic Technologies Program, one of the authors on today's report. And I'm here with our distinguished panelists, Kurt Dukes from the NSA's Information Assurance Directorate, and Chris Smith, who is from AT&T's Government Relations Office. So before we get into our panel, I wanted to tell you a little bit about our efforts on this report and the research that we did at CSIS. So we started this project in the spring with the question really, how can the military better leverage the Internet of Things technologies that are transforming the way that industry does business in order to accomplish their mission? And when we talk about IoT, Sean O'Keefe had given a little bit of an overview, but we really thought about it specifically as systems that integrate a number of component technologies, embedded sensors, connectivity, digital analytics, and automation. And through the synergy of these different systems, generate new value from data. So the way that companies do business has really been transformed, everything from complex industrial processes, personnel management, all the way to complex and dangerous programs like mining and manufacturing. And many of these technologies actually grew out of components that were developed by the Department of Defense. So Sean O'Keefe had mentioned ARPANET, but also really the modern microelectronics industry grew out of many technologies that were originally developed for defense applications. So when we thought about this problem, we were really looking at how has the Defense Department gone from a leader in technology development to an organization that has struggled to provide the basic functionalities of modern smartphones to their civilian employees, much less to soldiers at the tactical edge. And we approached this problem in a number of ways, but one of the key things that contributed to this was our conversations with 28 leading experts on these issues. They ranged from technical experts to industry folks, military leaders, Pentagon executives, but also troops who have actually been in the field and have used these technologies. And we came away with a number of observations that we included in our report. One being that DoD is using a lot of IoT component technologies already. In particular, in the C4ISR and in the fire control space, DoD has really adopted a lot of the technological innovations using embedded sensors and automation to guide weapons, particularly, for example, defensive systems on Navy ships. They've also used some of these technologies in their management and back office systems, using systems like the Global Combat Support System for logistics management, which is a data integration platform that delivers a lot of value to logistics officers at all levels of the command structure. But there are also some significant gaps in the way that the military is using these technologies. And one of the most important ones is those synergies I talked about, having all of the components working together to maximize the value of the data that they generate. And in the military, you don't see that as much. Typically, there's either manual data entry at some stage. Data from sensors is collected by a human being and typed into another system, or passed manually from system to system. Much of the analytics is done by human beings, and because that's difficult to scale, often data doesn't get analyzed at all, or data that might be useful in one system is segregated in a separate system. So finally, there's a number of applications where you don't get the benefits of speed and of you introduce human error into systems in a way that a lot of industrial processes have tried to avoid. But there's another side to this. The military faces some pretty unique hurdles in the adoption of IoT technologies, and arguably the most important is security and operational assurance. No one wants to be calling IT support from a foxhole saying, my radio isn't working, my smartphone isn't working, I can't accomplish my mission. And so there needs to be a new approach, resiliency, that General Cartwright talked about, but also security for these systems against adversaries with advanced cyber capabilities, advanced electronic warfare capabilities, and simply the ability to physically destroy some of these devices and systems on which we depend, for example, our space-based systems. There are also is a need for IoT enabling technologies. So a leading Army officer who works in the IT space said a few months ago that even if he had a full suite of IoT devices that he could issue to every soldier, he doesn't have all of the connectivity, all of the analytical support that he would need to leverage the value of those systems. And that's something that the military needs to build out. And that needs to be built out in a way that ensures interoperability and convergence of those systems to ensure that the data can interact and can be used by all of the relevant stakeholders. Finally, as General Cartwright mentioned, cultural hurdles are a big problem. And some of those are very legitimate, you know. As he said, the risk aversion of many military figures is based on the fact that if systems fail, people die. That's an unacceptable outcome, and that's often not the case with commercial systems and commercial applications. But that might be taken to an extreme. I think there are some military officers who would be more comfortable if we issued really long oars on aircraft carriers just in case the engines didn't work. And that approach is probably not the most constructive for the future of the third offset of using automation to enable the military. There's also the budget problem and the fact that a number of the experts we talked to in this report, they said, you know, the military does not spend dollars today to save dollars tomorrow, which is in many ways how industry has developed real value from IoT. You invest in a new system today, and you save on the efficiencies you generate over time. And finally, this issue of cultural clash with Silicon Valley is something that the department is actively trying to address, but there are some fundamental conflicts of values here. For example, the issues of export controls, of controls on the use of technologies that are used for military applications. That's something that makes sense for the military in many ways, but is unacceptable to many in the technology community. Similarly, controls on intellectual property and who owns the technology and the innovation that's done with federal money or used for federal applications. So in doing this report, we really tried to focus on things that the Department of Defense can do now to better leverage these technologies. And we identified three main areas. The first is identifying cost-saving efficiencies from these technologies that can be implemented today using practices already adopted in the commercial sector. These are things like condition-based maintenance, real-time fleet management, inventory and supply chain management end-to-end, and basin facilities management using embedded sensors. These can generate significant efficiencies in things like energy use, acquisitions cost, manufacturing plans, and order flow. But there's also the IoT enabling technologies that I talked about. Developing flexible, resilient connectivity that can be pushed out in large volumes to the tactical edge is going to require investment in things like new generations of communications drones, small resilient satellites, and even in many cases using commercial satellites to deliver that connectivity around the world. There's also security protocols to enable the department to use commercial devices, something that was talked about by General Cartwright, but is also something that our panelists know quite a lot about. So we'll talk about that a little more. And finally, developing common standards that facilitate convergence and interoperability. And again, this is something that the department is making an effort at, but where there's a lot more room to advance. So all this taken together is to say that the military is doing a lot with these technologies. There's room to do a lot more. There are steps that can be taken now, and hopefully our distinguished panelists are going to be able to talk to us a little bit more about some of these challenges and the way forward. So our first panelist on the right is Curtis Dukes. He's the director of the Information Assurance Directorate at NSA. He's spent more than 30 years in government service. He joined the NSA in 1984. And he's worked in a number of positions in systems and network analysis, the Commercial Solutions Center, really doing everything on cybersecurity, cryptography, and information systems security. Our second panelist, Chris Smith, is Vice President for Technology at AT&T Government Solutions. Before that, he was the Chief Technology and Innovation Officer at Accenture Federal Services. And before that, he actually spent decades in government service, both as an employee at the GSA and IRS and as CIO at the Department of Agriculture, and also 25 years as an active and reserve military member as a Joint Tactical Communications Officer for the Air Force. So they both bring a lot of really great experience to this, and we look forward to hearing their thoughts on these issues.
Curtis, you want to start?
Yep.
Curtis?
First, a bit more introduction. I have the privilege of running the Information Assurance Directorate in the National Security Agency. As you may be aware, the agency actually has two missions. First and foremost is foreign intelligence, but I think equally and actually more importantly is the protection of U.S. communications as well as partner communications, and how we go about protecting that. We've had a rich 60-year history of from actually doing the design to the development to the manufacturing of these devices that protect these communications. In the last decade, we've actually made a structural shift away from doing it all internally inside the NSA to actually adopting more and more commercial technology. What brought that about for us was the onset of mobile platforms and mobile communications. The Defense Department has always had a history of being first to market in these type of technologies, but what we didn't see is the adoption of smartphones and with Apple's iPhone in that regard. So we've made this fundamental shift, and so what we're doing now is looking at how you layer commercial technology together securely that can actually be used to protect U.S. classified communications in this regard. We're also big adopters of looking at innovation and what that can do for us. And so we partner with In-Q-Tel, which is a venture strategy firm within the intelligence community, to actually spot and assess these young, innovative companies, and then actually develop a work plan for that. The final piece when it comes to Internet of Things, again, I think as you heard, we, the Defense Department and NSA as a combat support agency has always been first and foremost in how you think about sensors. So, but again, what's happened in the last decade or two is that there's a new economy that's kind of sprung up. That actually everything is now is a sensor. Everything is collecting information about your habits, whether it's medical, whether it's about aerobics, whether it's about your purchasing habits, and it's created this concept of data analytics and data scientists to actually then be able to then offer you additional products and services in that regard. So that's been a fundamental shift for us, and why I think we've started to lag a little bit in adopting Internet of Things. From an NSA perspective, there are three key things that we worry about. First and foremost is security. Are these devices collecting the information securely, and then how they actually are storing and forwarding that information back to these analytic engines where they're compressing it and then actually making automated decisions based off that. The second piece of this is standardization. There's a lack of standards when it comes to how you actually securely communicate with everything being internet aware, and and also how that communication stream looks there. There's complexities based on that in the sense that traditional cryptography, we have to rethink that. We have to go to more of a lightweight-based cryptography because these devices don't have the processing capability that traditional communications devices have. So we have to look at different protocols and standards in that regard. And third and finally, it's data and privatization of that data. What I mean by that is that within the Defense Department, we acknowledge and as right of employment there that our willingness to give up certain privacy in that regard. But again, there is this competing economy now with the Defense Department, And you as users also have rights and have privacy concerns. And so you should have the right to either opt in or opt out depending on your desires to whether or not you want that information collected about your habits and things of that nature. So those are the 3 areas that we're focused on. We do talk frequently with industry on progressing on securing this global sensor of internet-aware technologies.
Thanks, Curtis. Hey, well, thanks to everybody for persevering through the traffic, and anybody who was worried about whether fall was going to show up or not this year. It certainly came with gusto this morning. Thanks for the perseverance. Will, thanks for the report, and to your authors and co-authors, to Denise, the Center for Strategic and International Studies. I think a great piece of work talking about the opportunities and challenges. One of the most exciting things, I think, technologically that we'll see in our lifetimes. And certainly General Cartwright always with great insights. And then it's not lost on me with Shawn O'Keefe standing up there, how long we've been in the sensor business out in space and the Deep Space Network and bringing information back. So these things are not new. They're just taking off at a rate which can be mind-boggling. The connectedness of our world, it just happens at a more and more rapid pace. It's exciting. It can also be maddening. I mean, I think if you look out there and say there's more devices than there are human beings now, and think about what wearables are going to take us, right? Many people have 2 or 3 connected devices right now, and with wearables and our cars coming out at a rate that I don't know that anybody could have managed a few years ago. We're rolling 1 million cars off the assembly lines every quarter right now connected. Connected on the telematics side, so we've got better information on how vehicles are going to perform. It helps with safety. It makes it more economical to operate these vehicles. And then we've just got the connected side of what's happening too. These are mobile hotspots now for information that think about the failed uses out there where we couldn't push network in the past because of the cost, because of the remoteness of it. Now, if all vehicles are connected, you have kind of a mobile mesh network running out there that a lot of us have talked about. So it really, truly is exciting. This market alone, if you step back and you look at where IDC and Gartner are saying by 2025, somewhere between $3 and $6 trillion in spend all the way across the network, the sensors, the cloud computing, and it's really about the data though, right? If we step back and we talk about this connectedness, if our cars are going to be connected to our homes, and our homes are now smart and we can control them, and our businesses are connected, it means that we can operate with information that we want at our disposal anytime, anywhere, any place. You could take a civilian agency example of an organization out in the field looking at the dam infrastructure of this nation, for example, where they used to have to travel hundreds of miles, do engineering studies, and then come back. Now, on the fly, they can have everything they need there to make that inspection happen. Or our forest firefighters, right, can have more information from overhead drones, the maps, the weather, where their teams are. We can more quickly save life and limb. On the battlefield, if it's situational awareness, it's those 3 or 4 pieces of information that an information maneuver unit needs. And let me tell you, you don't want to be looking down for that information. You want to be looking up and outward, so you're not losing your situational awareness. It really is staggering. So think about that connection that's going on, and then start applying that to the mission set, as I just started to do, or to the supply chain on the planet right now. One of the largest container organizations, the biggest supply chain operations on the planet right now, more than 250,000 of their refrigerated containers now are sensors, right? So they've got information on where they are. Think about putting a sensor 5 levels of steel down in the middle of a ship in the middle of the Pacific Ocean and being able to know where that is and how quickly it's going to get somewhere. Critical asset tracking is going to be different than it ever has. So I think the report just did an outstanding job of saying, hey, what's the opportunity out there and where are we going to go? But what are some of the challenges? Because we've got to go into this eyes wide open. If we are going to improve the supply chain out to the furthest points of the planet, right, we've got to do that in a secure manner. That means from the sensor across the network to where that information is computed and then put back out very quickly. So we've got to take a look at what's happening. I'm very excited for the conversation. The last thing I'll say on this front is how you're going to do that at scale. Because when we talk about the mission sets, either in the civilian agency, in the government, or we're talking about supply chain of the Department of Defense, these are some of the largest enterprises on the planet. The government civilian non-tactical fleet through GSA and other agencies, about 450,000 vehicles on the road today. There's another 200 and some odd thousand non-tactical postal vehicles that are out there. Think about 650,000 cars and the difference it could make if we more smartly route those If we replace them only when we need to, the savings are in the hundreds of millions to billions of dollars. Add to that the tactical fleet. I mean, right now we're looking at, Army has just announced, the next Joint Light Tactical Vehicle, 55,000 of these vehicles that we're going to put out all over the globe. How do those interact with other pieces of machinery that are out there? So I really am bully on the future, and I'm looking forward to the conversation.
Great, thank you guys. So maybe as a starting point, I'd like to get both of your perspectives. You know, we talked about some of the unique challenges facing the military, and Chris, you mentioned other branches of government and where they can leverage IoT technologies for greater efficiencies. Maybe from each of your perspectives, from the security perspective and from the industry perspective, can you talk a little bit about what makes DoD unique in your eyes, and what does it have in common with industry and with other parts of government, where it can maybe take lessons from those areas and apply them to its adaptation of IoT?
Yeah, so first and foremost, I mean, for the Defense Department, we worry about that last tactical mile. And what I mean by that is you know, down to squad and platoon level, and that being able to, where they're positioned, what type of weaponry they have, and things of that nature. You want to have a great sensor network to protect them, but it's a bandwidth constrained environment for them. If you look at that compared to the commercial model, you know, where you know you have good data pipes, and so you know they don't worry about you know the amount of data that's moving, that's being collected on you. So that's one area where there is a distinct difference between the Defense Department and the commercial sector in that regard. So we worry about compressing that data, only taking the right data we need to push it back to an operations center so that we can then maneuver those forces as necessary. The other big change, or the other big difference between the Defense Department and the commercial sector is that we don't want an adversary to know, again, where our tactical forces are located. And so when, as opposed to in today's environment with your mobile platform, you know, you want location-based services enabled, and you know the vendors want you to have that, want to know that about that as well. But in the military, we don't want that, because again, we want to deny that, from the attacker, from the adversary's standpoint. And so, that's why it's very important. Low probability of intercept and low probability of detection in this RF environment. You want to manage that, and that is just simply not a concern within the consumer model for that.
Yeah, I would agree with Curtis, right? That the need to operate detached wherever you need to be, and to be a homogeneous unit to execute the mission is critical, and most organizations don't ever face that ultimately, and it's life and death, right? And it's where success is based. What's interesting, there's some capabilities for teams like that, and they've done it for many years, to operate at will and to do that, and I think some of the technologies are going to allow, for the sensors to go off for a limited amount of time. But operational security, I was pounded into my head during the Cold War, right, about operational security, electronics intelligence, signal intelligence. If the enemy could see what you were doing out there, it was a huge disadvantage to you, because surprise is one of those things we always want to do. So, but if you step back and we try to go the other way and say, where are the corollaries? I think they're huge, right? And I think that's the right place to begin. I don't know what I would start with, the completely mission critical system to go try something new. It's generally not how we do it, although we do a lot of tests out there in the Department of Defense. So in my prior life, if I look back, it was really about from where I started my day at home to what I did on a base. And then if I was actually deploying, what happened, in that exercise environment where perhaps we're training people up through live fire and getting people ready to go overseas, or sometimes you bypass that and you go immediately to a contingency. And if we think of that spectrum and then forward operating bases, I think everything all the way up to that forward operating base, and then at the forward operating base, there's a ton of opportunity. The fleet is one of those areas that I talked about. AT&T has about a 75,000 vehicle fleet right now, which we're doing great things with. We're routing people more intelligently. We're saving money on fuel. We do more than condition-based maintenance, which is a great program, and the Department of Defense has saved tens of hundreds of millions of dollars, let's say if not even billions of dollars, right, is replacing parts before they wear out based on good trend analysis. But what's happening with the Internet of Things, though, is we're doing every point in that supply chain, and everything is a entity unto itself. So instead of replacing batteries, let's say, every 2 years because we know they're going to wear out, you can actually run across each battery and right in each set of brakes and every component within there and say, no, we're starting to see the factor on this vehicle, go replace it now, so you don't break down somewhere, have to send an under convoy out to pick that up, right, depending on where you are and what's happening. So I think fleet is a huge area, and I think you guys touched very well on that in the documents. I think our bases too, right, if you think about them as almost cities unto themselves, yes, they're certainly tied to the local community, but they also operate in many cases as their own entities. I mean, some of our bases and exercise areas are huge in terms of the land that they have, and we have people living on them. We've got facilities, we've got classified areas. So I think if we treat what we're doing with our smarter cities, where I talked a little bit about cars being connected, I mean, where this is going, right, is vehicle to vehicle and vehicle to infrastructure communications, so that our street lights, our poles, our traffic signals are all connected together. I think on the basis there's opportunities around that, around traffic management and infrastructure, we call it smarter cities, just huge opportunities. So I think the opportunities are actually greater in the aggregate than they are smaller and different than what's happening out there. But I think we have to balance that, right? All that information still needs to be treated very securely. It needs to not be, accessible to the outside. I think there's ways to do that with closed networks, maybe that aren't on the other parts of the network as well.
So, Kurt, maybe you can tell us a little bit more. You previously worked at the NSA's Commercial Solutions Group. And I'd be interested to hear, when you thought about how to provide a scalable solution to secure devices up to DoD standards, how did you do that? And one of the questions that was asked earlier mentioned this 6 hours to configure a single mobile device to carry secret classified, not even top secret classified data on military networks. How do you think about building a scalable solution that can be applied to the millions of IoT devices out there, and specifically to mobile devices, which are increasingly a key hub of IoT and facilitate that human-machine interaction that General Cartwright talked about?
Yeah, so as you might expect, from a security perspective, we kind of move slowly into the space, and so for years we actually developed our own mobile solutions in this regard, and like I said, in the last 5 to 7 years, we've actually started transitioning to all commercial base for that. And so our current secret level mobile device is an actual Samsung phone. The reason we went with Samsung was because of the Android operating system, and we could tailor that to our needs in this regard. But you're absolutely right. What we did is that we needed another independent layer of cryptography that would give us 2 layers in this regard. And actually, you can actually see our design. It's off of the NSA.gov website, in this case. And so for us, that was the easiest way for us to scale up. So what we now have is, by working with mobile OEMs, we can actually just buy procure their devices as is, and then we actually put our operating system, again Android based, on that with some additional applications for that, and then we allow that to be tied into our secret fabric in that regard. We do not yet allow BYOD, bring your own device, and so from us, that's the security balance is not there yet for us to be able for us to allow that within the Defense Department. But for an enterprise solution, it's scalable, and as far as configuration, we are constantly trying to reduce the time it actually takes to provision these devices. So within the Defense Department, and probably I would say large parts of the government, there are integrators that actually provide this service for us, and they are constantly trying to get that time frame down. So when one of these devices is issued to a person that's authorized to communicate securely, the device is already provisioned. They will be given a certificate with that. and then a PIN or password associated with it, and that's something they would have to know from that. But we're also, again, looking at how do we innovate that. So, some trying to move away from password PINs to some type of token of some sort, that's something that you have on your presence tied with some type of PIN. And those two factors would then unlock the device, and then you can actually communicate securely with that. But we're constantly looking at what where innovation is taking us, and I actually think these proximity sensors, that you can use to actually authenticate yourself is probably the next way for us to adopt within the mobile platform.
So I'll ask one more question, then I'll open it up to the audience here. Chris, AT&T is one of the major providers of connectivity, and really this is arguably one of the biggest hurdles that DoD will have to overcome in order to deploy a lot of devices, gather even more data, particularly in denied and constrained environments. And so as a provider of that kind of connectivity, what do you think are the most promising ways that DoD can get that connectivity to the tactical edge, and which hurdles are, at least for the moment, insurmountable?
So I think one of the key drivers to all this, and we've kind of been going over the top of it, but it's really the information, right, and the insight to carrying out the mission better, whether it's supply chain or, managing our bases better, or force generation, to the forward operating base. So it's that information, and what's happening to us in this world is connecting so much more rapidly with billions of sensors coming at us, is demand within the network is extraordinary. If you look back at 2000, across the entire internet, there was about an exabyte of information passed around. On wireless networks today, we're doing more than globally, everybody, more than an exabyte and a half. So think about that growth from 2000 to here. So I think what's incumbent upon, when you look at Department of Defense and the mission, is how we're going to keep up with and stay in front of adversaries with the need for bigger and bigger network connections, but also getting it right back down to the salient 3 to 5 points that somebody needs to operate to execute the mission, right? So there's a lot going on in technology with the ability to obviously store and look at more massive amounts of information. I always like to say it's not about finding the needle in the haystack anymore. It's how do you use haystacks to find the needles, right? So I think the reality is that everybody has a journey ahead of them on how are they going to keep up with that information and find the insights they're going to need to. So when you bring it back to the Department of Defense, I think there's a couple things going on. One is how do you secure at the edge and get information to devices that are more powerful in people's hands than they've ever been before and are going to continue to be. How do you do that securely, first and foremost? Second, how do you get the right amount of information in that individual's hands to do what their job is that they've got in front of them? And then third, I'd say it's actually more software, which is, everybody's becoming a software company. Software-defined networking is actually the thing that's going to allow us to keep up with those demands on bandwidth. So I gave you an example from 1 exabyte in a year in 2000 to about exabyte and a half of information coming at all of us. Think about how you're going to keep up with that, with over nearly 60% of that being video right now. And Department of Defense has actually led in this space in terms of surveillance and looking at what they need to execute their mission. How are you going to do that for video? So I think it's actually skating to the puck on the network side of things and looking at the investments that are being made. And I think it's one of the great strengths of our nation is that industry and government, executing in their own lanes, but there's a betterment ultimately for society and for how we actually do national security.
Great, so I'll open up to the floor here. I would ask that everyone please wait for the mic and introduce yourself before you ask your question. But yeah, who would like to ask a question? Got someone in the back there.
Hi, Alan Paller from SANS. Kurt, from the very beginning of the Internet of Things, sort of when printers were first connected, and all the way through to today, the manufacturers stick in things like Telnet with no password, or password is the password, or San Diego is the password, or something, San Jose. They put things in that make it easy to maintain, and then that spreads through the entire infrastructure, so it becomes completely open. When you ask vendors to fix that, they come up with one of the truly stupid things to say, which is, well, it works in a closed network, so you don't have to worry about that, which we've now seen doesn't really work that well. What's the game plan to try to use the government buying power to alter the manufacturer systems so that they're at least defensible, if not actually safe?
Yeah, so Alan, that's a great point. I mean, and you actually see that in the Internet of Things promulgating that same bad or poor security practice today. And you could think of maybe medical devices that are used to transmit information about, about the patient, at home to that, And so what typically what vendors will do is because of scale and economies, they'll either go with a single password or with something easily guessable in that regard, and they use their excuse, well, they are affording a level of security for that. What they don't realize is that it's easily guessable or from that. I think as we move to this, either they're going to have to do it per device, and it's part of that, that shipping, and then allow the user to then change that, which, by the way, is another poor practice. Typically, users don't actually change the default passwords on the home users. I don't know how many of you have printers or computers that you actually keep the same password time and time again. But the bottom line is I actually think either one of two things. Either they're going to have to start shipping with unique authentication for each device, or we have to come up with some type of identity management thing, and then as part of that acquisition, we moved that within the Defense Department. We enforce these measures through procedural methods, and so for every 90 days, I have to change my passwords. I don't get a choice. The operating system allows that to occur. But as you move to these Internet of Things, if we're not careful and if we don't think about building security into those devices at the onset, then we're going to have default passwords, that are easily guessable, and they are IP addressable. Therefore, they're reachable, and an adversary would be able to connect onto that and actually see what's going on. And what we find also is that these Internet of Things, they're also looking for what's the connection to your home wireless network, or connect to get out to the internet. So it may not always be RF based, and so in that regard, so that you could compromise your entire home network in that regard for that. But it really is forcing industry to actually start baking or building security into these devices.
I would just add, right, this is the fundamental hygiene stuff that organizations are constantly getting caught on. You got to do the blocking and tackling in the current environment with cybersecurity. It's not going to get any better. You got the patching, the scanning, the removing privilege access, or leaving it open to a default, Alan, as you just said. And I would go the next step further, is that whatever sensors, right, and whatever connectivity are laid out there, and then the app and the data that you do should be encrypted all the way across. If it's mission critical and it's something that others shouldn't see, then that's exactly what you do. You build that in all the way across the ecosystem of systems like this. And the one advantage you also get is by this network system is better insight to what's happening. And that's the thing with software. While you have to secure that software better than ever, you actually get to do a lot more predictive things, because you can bake in the baselines of how these, not only the network acts, but how does the application normally act at a given day, a week ago, a month ago. And when something happens, for the more nefarious threats that are out there, the harder to see, is you see that behavior, and that tips you off to something's coming at you or something's going on.
The one thing I would just add to that is that this is a DoD challenge, but this is also something that many in the government would like to promote as a practice in industry and for the consumer. And so maybe DoD can play a role in that, but it's also something that people from the NSA to the NIST folks across the federal government are interested in promoting for everyone and for all IoT. Maybe right up here.
Shawn Lewis with FCW. Curtis, you mentioned a lack of standards being sort of an impediment to leveraging IoT. I'm wondering what your agency can do to promote those standards. I know that's not really your lane. I think NIST does that. But what are you doing to help facilitate that? And then maybe if you could elaborate on, once those standards are in place, how that's going to make things that much better.
Yeah, so you're absolutely right that NIST has responsibility for promoting national standards and also into international standards organizations. But we do work closely with NIST on identifying, again, for DoD needs, but I also believe that it's not just DoD, it's actually for the entirety of a globally aware network. And so things like, it starts with asset management, just what are the protocols that actually identify every asset that's on a network, moving up to being able to send, threat intelligence information, and every device is collecting some amount of telemetry on the security state of that device, and how do you package that information and then send it securely. But also more importantly is that it will also affect how you can take automated courses of action. So you heard General Cartwright talk about the machine-human interface, and I think that's where we're getting if you really want to move into active cyber defense. These sensors are collecting information and then sending it to some type of orchestrator, which an orchestrator doesn't currently exist, or the ones that do exist today are based on a proprietary solution, not standards based. So we don't always get competition in that regard. But the point is that orchestrator would then be able to actually provide some type of near real-time response to some type of intrusion in that regard. But it first starts with what are our needs, and so it starts with an asset up to what that communication path is, what fields that we need collected about that device state, and then how we actually share that and then take action on that information. Many of those standards don't exist today. So what we with the National Security Agency are doing is looking at are there potential standards out there that we could actually use, and I could mention some in that regard that we are currently testing in some of our test networks, and then if it shows promise, then we would work with NIST to actually push that as first a national standard, but then also get it into an international standards organization. And the reason we'd want to do that is because not all IT products are actually built and manufactured here in the U.S. It's a global system, and so there are some great technologies that we would like to adopt, but we want those standards so that we can then use our acquisition and buying power to actually force those standards to be built into those products, so that we could then use that and actually have a more effective approach to cyber defense.
Another one in the middle.
Good morning. That was very interesting, thank you. I'm Chris McNulty from Applied Futures. And my question relates, in fact, to something you were just saying, Curtis. There are so many devices, and the numbers of them are increasing phenomenally, and the same with software. But we do outsource so much of the manufacturing of both the devices and the components and the development of the software to nations that are not entirely friendly. And the amount of counterfeiting that's going on, and the Department of Defense, the FBI, Customs and Immigration, so many departments have already suffered from that kind of counterfeiting. So are we not going to see the potential for that to increase just enormously as all these numbers of devices increase? And what can we do about them? Because random checks on shipments don't really produce an awful lot of results.
Yeah, so it's a great question. First and foremost, we live in a global supply system, and it can't be U.S. centric. We have to approach this problem, as a number of nations, and so what we have to do is establish some norms when it comes to, how a company authenticates, or how a company attest, that they followed certain design principles, and they've got a pragmatic supply chain process in that. So from an NSA perspective, we talked to a number of companies and asked them about their supply chain and what security controls they put into that regard. Counterfeiting is slightly different, and I think what you find is industry is starting to provide capabilities, to actually be able to detect whether a device is counterfeit or not. Currently, they don't scale, but I actually think industry is going to help us solve that problem in this regard. How we typically find counterfeit today within the Defense Department is when there is either a problem with the device, or we're looking to upgrade the operating system on that device, and so we call into the manufacturer to get that latest update, and that's when they check and they realize that this is a counterfeit device. Hugely expensive from an NSA perspective, simply because the next thing I know, I've got some number of products coming in for assessment. Basically, is this a nation-state supply attack, or is this just some small entrepreneur, if you will, that actually is actually trying to make a buck, a won, or whatever the currency is for them. But the bottom line is that I think this is going to take, from a government's perspective, actually levying certain supply chain requirements that we want to see industry attest to, and then also industry actually, because when it comes to counterfeit, they've got to help solve that problem themselves, and you see companies like Microsoft and Cisco and Juniper and others that actually have come up with some reasonable approaches to how they try to reduce the number of counterfeit devices for that. But we, first and foremost, it can't be just a U.S.-centric approach. It has to be globally addressed.
Chris, maybe you could say something about that, given your perspective.
Well, look, supply chain is critical to running one of the largest global IT platforms out there. Our network cannot go down because our customers are impacted, whether it's Department of Defense, a commercial entity, or a not-for-profit. So we spend a great deal of time and effort to ensure that our supply chain is secure, and we're constantly out there to be vigilant and to see where the changes are occurring and adjust.
Thank you. So do we have one last question?
So maybe, Will, this is for you. So there's a nice set of recommendations in the report. Pick any one. Which ones, or pick which ones are likely to come to fruition? Which ones need organizational help, to quote General Cartwright, to cause them to happen?
You get to start, Will, and then we'll jump in.
Okay. I think that you're already seeing some initiatives on DoD's part to try to build out the IoT supporting technologies, to adopt software-defined networking, new bundling to enable more use of devices, more data to flow across the networks. There's also some pretty extensive initiatives to better interface with Silicon Valley to access innovation in new ways. I think that those are probably the area where it's going to take the most work on DoD's part is on the accessing innovation. So you speak to folks in Silicon Valley, and while the new testbed at Moffett Field is helping in some ways, they still have their reservations. And as I mentioned earlier, there are some fundamental differences of approach and differences of values between the DoD and the private sector. And so someone's going to need to budge on that. And I think that given the way that industry is feeling towards the government right now, DoD might have to make the first step, at least something to build confidence or to make a gesture of good faith. So that might be an area that will take a little bit more work. Whereas the IoT Enabling Technologies in particular are something that I think DoD understands they need to invest in. That's an operational imperative going forward. And that's probably most likely to happen on its own, given where the momentum is now.
I would say fleet, non-tactical was a great place to start just because the efficiencies that are going to be gained are going to be extraordinary. And then supply chain, I think critical asset tracking, while great things have been done to date, the opportunity for real-time information with the sensors, the network, the security that are there today would also pay huge dividends.
Yep, so for me, first and foremost, security. You know, I think right now we really haven't thought through what the security model looks for this Internet of Things, and I think that's the first step. And then the second one is codifying, you know, those security perimeters into standards for that. And I think, you know, I think that's where the Defense Department and certainly my agency will be front and center trying to lead that, you know, in close partnership with NIST.
Great. So that's going to wrap up our panel. Thank you both so much for doing this. We
Thanks,
really
Will.
appreciate your thoughts on this topic.